Welcome all. In today's session, we will learn about rotate tool, insert tool, and mirror tool with the help of two examples. One of the example which I'll consider is a scissor type truss, and the another one will be lenticular truss. Now, based on these two problems, at the end, I'll give you one task which you can try out modeling in STAAD. So let us begin. So here we have a scissor type truss, and the dimensions are given as shown here. There can be several ways with which you can do the modeling. You can find the coordinates of the nodes or all the nodes as shown here, and then you can join those nodes in order to create the structure. But I want to create this model very quickly. So how we can proceed? This is not a standard type of truss which is defined in the structure wizard. So what to do? How we can model it very quickly? If I see this part of the truss, this part, one of the part of the truss, this is what type of truss? This is a hollow roof truss. So if I can model this hollow roof truss, okay, this part of the truss, then it is possible by mirroring this part, by placing a mirror over here, I can mirror this and I can complete the model. So let us imagine the truss, this hollow roof truss, is being placed like this. Now what I need to do, I need to rotate this truss, right? If I would like to rotate this truss such that this part of the truss forms the inner part. So I'll determine that angle by how much it is going to be rotated. So let us start modeling this. So what is the length of this hollow roof truss which was given to you? So as it was given, one of these span is 3.6, 2.6, 2.6 and 3.6. So I can write equal to twice of 3.6 plus 2.6. So the span is 12.4 meter. And what is this rise of this roof truss? It is 1.7 meter. Okay. And how many bays you have? 1, 2, 3, 4. Okay, you have 4 bays. So I have the start window. Click geometry. Under geometry, click structure wizard. Here you see hollow roof. Click hollow roof. What was the length? Let's see, it was 12.4 meter. What was the number of bays? It was 4. And I'll be clicking this radio button. Since the bay length is unequal, it is 3.6, and here 2.6, 2.6 and 3.6. Click OK. Next, our height was 1.7 meter. We do not have any width, so I'll give it as 0. Click apply. You can see you have got this all. Now I will transfer this structural wizard model to my STAAD view window. To do that, you can see this icon transfer model. Or you can go with edit, add paste model in STAAD Pro. Click here this. Next, click yes, click OK. So this is the part which I have made. Next, I want to know this angle. The span of the truss is given as 17.8 meter. So from trigonometry, I can find this angle. So what will be this angle? So it will be cos theta equal to half of 17.8 meter, that is 0.5 into 17.8 divided by this hypotenuse. So this length is 12.4. Let us say I want to compute this in Microsoft Excel. So I'll do equal to a cos. This is for cos inverse function, 0.5 into 17.8 divided by 12.4. Here we'll get the angle in radians. So I want in degrees, so I'll multiply this with 180 divided by pi. So you get 44.13164 degree. I need to rotate this truss, considering this as base. So we have this angle theta equal to 44.1364 degree. And what will be this angle? It will be 180 minus 44.13164. So it will be equal to 180 minus 44.13164. So it is 135.8684. So basically, this truss has to be rotated by 135.8684 degree. So let us see how you can do that. This is my point about which I'll be rotating the truss. So let me go to view, see the isometric view. So about what axis I'm going to rotate? About Z axis I have to rotate. To use the rotate command, you have to go to geometry. Now under geometry, you can see this icon and you get this tool type generate rotate. Click generate rotate. Here you can specify the angle. Please note your clockwise rotation will be negative, anti-clockwise rotation will be positive. Here it has been mentioned axis passes through node. So you can define the axis. Okay, you can define the axis. Now to define the axis, you need two nodes, node number 1 and node number 2. It means that axis is going to pass through these two nodes. So before using the rotation command, I need to define the Z axis. I do not have the two node which is going to give me the Z axis, because whatever model I have made, it is in my XY plane. So let me create one dummy node which is will be along Z axis. So I'll go to select, let me click node cursor, select this node cursor, control C, control V and Z, any distance you give. This is a dummy node which I'll be deleting later. So say this is at 2 meter, click OK. So my axis is going to pass through these two node. All right, when I'm using rotate command, my axis is going to pass through this two node and it is going to be what? Along Z axis. Before using rotate command, what I want to rotate? I want to rotate all the members. So get into the beam cursor. So click on this view window and press escape. This is the beam cursor which you get. Select all the members. Now under geometry menu command, click this icon which is generate rotate. Now what was the angle? If you see, the angle was 135.8684. So I'm going to rotate this in which direction? In a clockwise direction. So minus 135.8684. Through which axis should pass? I'll click this icon, click this node. So this is showing me node number 5, and click this icon and click this node. This is my node 1 and this is my node number 2. Now I want to move this, so select move. Now click OK. Click OK. So here you see one of the part you have got. Okay, so what I'll do next, I will delete this dummy node. After rotation, you'll get this part of the structure. Next, I can place my mirror over here. I can make a mirror image of this part of the truss. And from where the mirror will pass, it will pass through this node, right? So let us see how we can use mirror tool in STAAD. To do that, what I want to mirror? I want to mirror this entire beam, and about which plane I have to keep my mirror. I have to keep my mirror in YZ plane. Let me go to view. Let us see the isometric view. So my plane should pass through this node, and the plane has to be what? YZ. Okay. So if I keep my plane about YZ, this selection will be copied along my XY plane. So I need to make a mirror of these selected beams. So once you select these beams, go to geometry. In geometry, here is this icon which will activate the mirror command. So click mirror command. where we need to have this mirror plane, it should be YZ. So click YZ plane. Where is the node which is containing that YZ plane? So that I need to define. So click this particular icon. So once I click this icon, click this node, because this node is containing that YZ plane. Next, I want to copy this. So make the selection of copy, click OK. So here you see one of the part of the scissor type truss has been created. Let us go to view, select the front view. Here it is. Next, I'll join these two nodes. Click geometry, add beam, join these two nodes. Done. As you can see, I have one node in between these two nodal points. So what I can do, get into the beam cursor, select this node, make a right click, and you can see this option insert node. Or select this node, click geometry, under beam you have this insert node option. So you can click this and you can activate this insert node command also. So you have two ways, as I said, make the selection of the beam, make a right click, click insert node, same option you get, or under geometry menu command with this beam option, you have this insert node command. By the way, you can do that. Click insert node. What I want midpoint. If you click midpoint, you can observe exactly at mid, you can create the node. Okay. There are other options also. Let me tell you. Like say here, this is insertion option. Click remove. Here you see this distance. Say from node 7, I want at a distance of 1 meter this particular node. But whenever you are specifying this distance with reference to the start point of the beam, this distance is being defined. Let me tell you how you can know the start point of the beam. Now to know the start point of the beam, let me cancel this out. What you do, you press Shift E. Shift E. I'll repeat, Shift E. So whatever green line, like if I say see this beam element, this green color is indicating the start point. Alright, like if I go to this beam, so for this beam the start point is this one, and this blue is indicating end point. You press Shift E again. Now make a selection, click insert node. So whatever distance I'm specifying, it is with reference to my start point of the beam. So I'm knowing my start point is over here. Here it was my green color, right? Say if I specify distance as 1 meter, click add new point. You see from node 7 it is specifying. So whatever node 7 is there, that is my start point, and you can click OK and you can see from here it has been specifying 1 meter. But I do not want the node at this particular location. I want exactly at between. I'll press Ctrl Z to undo this. Make the selection. Click insert node, add midpoint. Click OK. So exactly at center, you get the node. Next, join these two nodes. So with this, we have completed the geometry. And to confirm whether the geometry is correct or not, go to node tools, select node to node distance, and check whether it is correct. See 3.6, 2.6, 2.6, 3.6. This height has to be how much? 1.7 meter. And this span should be how much? 17.8. So we are having that. I hope you have understood how to use rotate command, mirror command, and insert node command in STAAD. Next, again, we'll take up one more truss problem, and here the geometry will be little bit more different, and we'll see how we can model that in STAAD. Before we get into the cylindrical truss problem, I would like to tell you one more important point regarding insertion of nodes. Say in this member, in between these two nodes, I want to insert 3 nodes which is being equally spaced. Now to do that, make this selection, make a right click and click insert node, and here you specify how many points, 3 points, n equal to 3, add n points. You can see uh, there are 3 nodes which has been inserted between these 2 nodal points. Now click OK. You can see you have 3 nodes which is present between these 2 nodes, and you can measure the distance. As I said, distance is going to be equally spaced, 1.384 meter, 1.384 meter, 1.384 meter, 1.384 meter. So this is also one of the way with which you can insert nodes. Suppose if nodes are equally spaced, and if you know how many number of node has to be inserted in between 2 points using the entry of n, you can do that. Now we will start with the lenticular truss problem. Well, I was talking about this problem. This is a lenticular truss. This is also called as pumpkin seed truss or fish belly truss. It can be observed from here that the shape of the curve is parabola. My intention is to model this truss considering one of the frame. So let me model this particular frame. Now to do the modeling of this frame, as you can observe, this truss is inclined. Okay, this truss is inclined, and this is actually supporting a walkway, which can be seen over here. So I need to know what is the RL at this particular location and also at this particular location. So from here you get this data. RL here it is given as 293.60 feet, and at this particular location it is 299.60 feet. If I know this, I will be knowing at what inclination this particular truss has been inclined with horizontal. Let me take the screenshot of this truss. This is the truss. As you can see, the horizontal dimension is 92 feet, and the difference between RL in this point and this point is going to be 6 feet. What we'll do, we will model this truss as a horizontal truss, and then we'll rotate this with the required angle. So right now I want to know what is the length of the truss. The horizontal span which is given is 92 feet, and the difference between the RL of these 2 points is 6 feet. So what is the length of the truss? So the length of the truss, it is 92.19544 feet. Let me convert this into inches, equal to this into 12. So the span is 1106.345 inches. So as I said, what I will do, I will try to model this truss such that it is horizontal, and later I am going to rotate it by the required angle. And by what angle I will be rotating? So equal to, so it will be tan inverse of how much? How much was the rise? It was 6, and the horizontal span was 92. Since it will come in radians, I will multiply this with 180 divided by 5. So the angle is 3.731397 degrees. Fine. What I can observe, if I know the nodal location of these points, and if I connect these nodes using beam element, I'd be able to make the truss. What I will do, I will draw the one half of the truss, and then I'm going to mirror it. Okay, and also my observation indicates that whatever these verticals which you see, these are being equally spaced. Now in order to know the coordinates of these nodes, what I need to do, I need to know the equation of this parabola. Also I want to know the equation of this particular parabola. These both parabola have different rises. As you can see over here, this parabola is having a rise of 5 feet 2 inch, while the bottom part is having a rise of 2 feet 6 inches. We know the equation of parabola. What is the equation of a parabola? The standard equation of a parabola is y equal to 4 into hx L minus x by L square. So this is the equation of a parabola, considering this as the origin. So what is the x coordinate at this particular point? So it will be how much? Since, as I said, these verticals has been equally spaced, the x coordinate over here will be how much? So whatever span you have, you divide this into 20 parts. If I divide this into 20 parts, it will be how much? Equal to this divided by 20. It is 55.31727. So exactly at 55.31727, I want to know what is the y coordinate. So that can be done. What you have to do? So let me write equal to 4 into what is the rise? 5 feet 2 inches. So since I'm going to do my calculation in inches, so it will be 62 inches. So 4 into 62, 4h into what is x? This is x into length. So what is the length? 1106.345. So let me fix this value by giving this dollar sign. L minus x divided by L square. Again, this 1106.345. I'll fix this value square. So at a distance of 55.31727, with reference to this node, the y coordinate is 11.78. Similarly, at x equal to 0, you have this value as 0. So next, I need to know at this particular point what will be the y coordinate. This point, what will be the y coordinate? Up till here, I would like to know the nodal values. So to do that, what will be the next? So next coordinate will be what? This will be equal to, as I said, this distance was divided into 20 parts plus this. So 10.6345 you get. Next, drag this. It is coming 22.32. What I will do, I'll select these two values, drag this till you get 62. So here you see at 553.1727 the rise is 62 inches. So I have got the nodal coordinates of these points, capital half span. Next, I want to know the coordinates of these nodes which are below this line. Okay, so I need to know the coordinates of the curve, parabolic curve, which is given below. As I said, this is my reference node. These nodes is being placed in the vertical downward direction. So it will be negative. So what will be the equation? It will be equal to minus 4 into the rise is how much? 2 feet 6 inch for this parabola. That is 30 inches. 4h into this is my x into this length. This length I'll fix by giving dollar sign L minus x divided by again this length square. It is minus 5.7. I'll select this. Once this cursor comes at this particular corner, drag this. So here is the nodal coordinate of the second parabola. So let us see how we can do that. What I am going to do is, let me place this over here. Let me make a copy of this x coordinate. But when you copy this, paste this as the values. Once this is done, please remember this is my x coordinate and this is my y coordinate. And the geometry, since our units has to be in inches, the nodal coordinate has to be in inches, because the nodal coordinate whatever we have computed, these have unit of inches. We'd like to change the unit which is coming over here. To do that, under geometry, you can see this icon. This is for changing the input unit. Click this. Now click custom. The length unit which I want is inch. Click inch. Click apply. So here you see you change the input unit. So at any point of time, if you want to change the unit, click geometry. Under geometry, this tool input units. If I want to have unit as millimeter, if you click millimeter, click apply, you can see it is millimeter. Anyhow, I have this unit as inches. So click inch, click apply, and I have to make the entry of the coordinates of the node for the upper parabola and the bottom parabola of the lenticular truss. To do that, quickly, I'm going to make a copy of these nodes. I'll make Control C. Select this number 1 in this way, such that all these coordinate of XYZ is highlighted in black color. Make Control V, because I'm pasting the nodes. Remember column 1, I know column 1 is what? Which coordinate? It is X coordinate. Click X. Column 2 is what? It is Y coordinate. Click Y. Click OK. So you have the coordinates of the upper part of the lenticular truss. Next, same thing will be repeated for the nodes of the bottom part of the truss. So I need to copy this and paste just like we did for the upper part of the truss. But here you see, if I copy this entire, already this coordinate 0, 0 has been defined. So it is advisable you select these nodal coordinates. But say you have done this, you have copied this 0, 0, make Control C, select this node number 12, make Control V. So I know, see, if I select column 1, I am not getting this option. To get this option, select one time column 2, then go to column 1. Then you select column 1 is my X coordinate, column 2 is my Y coordinate, and click OK. I know here whatever node you are seeing over here, press Shift N and press Shift N. Here actually you have two nodes, node number 1 and node number 12. But how I'm saying this, because I have node 1 as 0, 0, 0, and even I have node number 12 which is 0, 0, 0. But suppose if you have lot of nodes, you won't be able to identify whether you are going to have duplicate nodes or not. Now to identify whether you have duplicate nodes or not, go to utilities. Under utilities, click node tools. Okay, but before that, it's been to select in this particular window, the view window, click utilities. Under node tools, click this option of duplicate nodes. Enter your tolerance, click OK. Here you see it is showing me the list where you have this duplicate node. Whenever you are modeling, try not to have duplicate nodes and duplicate beams, because it is possible that it will lead to incorrect analysis result. So I need to merge this, or I need to remove the duplicate node. So highlight this, click remove all duplicates, and make selection of OK. You can see that duplicate node has been deleted. That is node number 12 is no more, and you can check from this node table. See, node number 12 has been deleted. Next, go to view, see the front view. What we'll do, we will join the created node using beam element. Go to geometry, click add beam, start joining it. So once this is completed, you can see the upper chord and bottom chord of the lenticular truss has been done. It has been made. Click on this window and press escape. If you see the truss, you can see you have these verticals. These nodes has to be joined by these verticals. I want to speed up this work. I can see this node 2 and node 13 is to be joined along y-axis. Similarly, node 3 and node 14 has to be joined along y-axis. So what I'll do, I'll go to select, make this node cursor, select all these nodes which has to be joined along y-axis. Click geometry. Under the beam option, you see this particular icon. It is showing you connect beams. Select this drop down menu, selecting this triangle. You see y-axis. If you select this, you see the verticals have been created. Now this option connect beam can be used to connect nodes which are parallel to x-axis, which is parallel to y-axis, and which is parallel to z-axis. So I have used this tool to speed up creating elements which is connecting the nodes which are lying parallel to y-axis. So we have created the verticals. Next we have to include the inclined members. So inclined members, I cannot use this tool of connect beams because like if I join 3 and 13, it is not parallel to any of the axes. So this has to be done manually. So click add beam, start joining it. Well, so we have done the half part of the lenticular truss. Next, we will mirror this half part in order to make the complete span of lenticular truss. To do that, what we have to do? We have to place my mirror along what axis? Along YZ axis, such that this members which is lying in XY plane gets mirrored along XY plane itself. So my mirror has to be in what? YZ plane. And about which node it should pass? It should pass through node 11 and 22. So that mirror should contain node 11 and node number 22. So let us do that. Select on this empty space, press escape, you'll get the beam cursor. Select all the beams except this one. If you select this beam and make a mirror image, this particular member is going to get duplicated, and I don't want that. Okay, so that is why I have selected this part of the member only. Go to geometry, select mirror. The mirror has to be in the YZ plane, and about what position or about which node. So select this icon. So I know 11 and 22 has to lie on that particular YZ plane. So let us select 22, make a selection for copy, click OK. So we have completed this modeling of the lenticular truss. But please note the problem which I had given, this lenticular truss is inclined, and we had found by how much angle it is inclined at an angle of 3.731397 degree. What we have to do? We need to rotate this lenticular truss about which axis? About z axis. Okay, about z axis. So let me go to view, go to isometric view. So this entire truss has to be rotated about z axis. You remember when we used this rotate tool in STAAD, we have to define the axis about which members or nodes has to be rotated. So I have to define that particular axis. And to define the axis, we need two nodes. I do not have any of the node which is lying about z axis. So I'll be creating one dummy node. To create this dummy node, click select, click node cursor. So I know this truss has to be rotated about node number 23. Click 23, Control C, Control V, about Z, say 100 inches. Click OK. I have created a dummy node. So this dummy node has been created such that I can command STAAD that it has to be rotated about axis which passes through node 23 and node 42. So next, let us rotate this. To rotate it, press on this window, click escape, you get beam cursor, select all the members. All the members has to be rotated about the axis which passes through node 23 and 42. Go to geometry, select generate rotate. At what angle? So about node number 23, this entire truss has to be rotated by 3.7313 degree in clockwise direction. So it will be minus 3.7313 degree. About which axis? Node 1. This is my node 2. So about this axis, this has to be rotated. What I'm doing, I have to move it. So make a selection on move. Click OK. Okay, so next I'll be deleting this dummy node. Select on the select menu, click node cursor, select node 42, delete it. Let us see the front view, click view, see the front view. This is the lenticular truss which you have. So this completes this session, and in this session we had explored how to use rotate tool, mirror tool, and insert command tool in STAAD. Let me give you an activity. What I am asking you, I'm asking you to model this problem. Well, this is the network arch bridge. This arch is in parabolic in shape, and this is the model which you have to create. Actually, these are the dimensions which has been specified. Please note the rise is 5 meter, vertical height is 5 meter. Okay, so please try modeling this. Thank you all.